Okay, you may pause the video and try this by yourself first. So we have 100 grams of iron sample at initial temperature 100 degrees. It's added to 50 grams of water. Water's initial temperature is that. So what's going on here? So we got water here. We got water, but then we put hot iron ball into the water here. What will happen after time goes by, where thermal equilibrium has reached? Then all the heat that came from iron got absorbed. Well, heat is released from the iron, and the same amount of heat is absorbed by the water. So Q for iron is going to equal to Q for water only if one is negative, because heat is released, meaning Q will be negative for iron side, and then Q for water side will be positive. They're gonna be the same number, but then signs will be different. So in order to be equal to each other, you have to put negative either left side or right side. It doesn't really matter where you put it. I'm just gonna put it in the left side. Okay, so that's our situation here. And then we got all these data. Let's work with Q equals MC delta T for both of them. So we have Q for iron should equal to negative Q for iron should equal to Q for water here. Okay, then negative MC delta T. Remember this MC delta T, MC delta T for water side, for iron side. So negative M is 100.0. This time I'm gonna omit the units. Okay, and then specific heat is 0.450. But then make sure that this is in K, so you have to change the temperature into kelvins as well. So that's specific heat. Temperature, T final, we don't know. They're gonna reach the exact same T final because they're gonna reach thermal equilibrium there. Okay, so T final minus, you gotta change that to kelvins because this is in kelvins. So 100 plus 273, I'm just gonna use 273 plus 100 here, okay? So it's gonna be 373 kelvins. Okay, that's gonna be equal to the water side. Water M will be 50.0 grams. Specific heat for water, I'm just gonna use 4.184. You have to check because different teachers would have different values here, okay? So I'm just gonna use 4.184 joules over grams per K. And then we're gonna have same T final. These T final will be the same minus initial temperature. So you add 273 to that. So 273 plus 26.5 will be 299.5. So 299.5 in kelvins. Okay. So let's multiply these two, and simplify. So this is going to be negative 45.0 times T final minus 373. This is going to be 209.2 T final minus times T final minus 299.5. Okay, now let's distribute. So I have negative 45.0 T final minus will make it plus, distribute 45 times 373. It's going to be 16785. 16785. It's going to equal to distribute 209.2 T final minus, I get 62655.4. I'm going to move it up a little bit. So I'll bring it down in a minute. Now I'm going to add TF on the right side and then add that amount on the left side. 209.2 TF plus 45.0 TF is going to be, if I add that, I mean, it's going to be 79440.4. Now I could add these TFs together. It's going to be 254.2 TF. It's going to be 79440.4. Now I divide. So my TF is going to be 79440.4 all over 254.2, which is going to be 312.5. And then this is in kelvins, so I need to minus. So I need to minus 312.5 with 273. I'm going to have it in Celsius. It's going to be 39.5 degrees Celsius. So let me make it smaller now. So that would be the final temperature of the water, which is 39.5 degrees Celsius.